Hello friends, I am Dr.V Department of Physics, Shivaji Arts, Commerce and Science College, Kannad. Now this is a Gaussian pillbox. Now in Gaussian pillbox, here is one plane and we have to determine the electric field due to this infinite plane. This carries uniform surface charge sigma, which is shown in figure. Now suppose A is the area and apply this Gauss law to the surface, that is closed integral of E dot dA is equal to Q intrinsic divided by epsilon naught. Now total area is 2A because for upper side and lower side of this pillbox. Therefore substitute the value of area, that is integration over closed E dot dA is equal to 2 into A mod of E. The sides of pillbox do not contribute anything to the intensity. 2A mod of E is equal to sigma into A divided by epsilon naught, because sigma is the surface charge density. Therefore electric field E is equal to sigma upon 2 epsilon naught dot n. N is the unit vector to the surface. Thus this equation is giving electric field due to an infinite plane which carries the charge sigma. Now uniqueness theorem. The first uniqueness theorem states that the solution to Laplace equation in some volume V is uniquely determined if V is specified on the boundary surface. Consider a volume as shown in figure, within which the charge density is equal to 0. Suppose that the value of electrostatic potential is specified at every point on the surface of this volume. A region and its boundary is shown in the figure above. Suppose there are two solutions to Laplace equation. First solution is lambda square V1 is equal to 0. Another is lambda square V2 del square V1 is equal to 0 and del square V2 is equal to 0. Since both V1 and V2 are solutions, they must have the same value on the boundary. Thus V1 is equal to V2 on the boundaries of the volume. Now consider a third boundary V3, which is the difference of V1 and V2, that is V3 is equal to V1 minus V2 and V1 is equal to V2. Therefore, the function V3 is also a solution of Laplace equation. This obeys Laplace equation. It is del square V3 is equal to del square V1 minus del square V2, which is equal to 0 because V1 is equal to V2. Therefore, del square V3 is also equal to 0. This proves that there are no two different functions V1 and V2 that are the solutions of Laplace equations and satisfy the same boundary conditions. Therefore, the solution of Laplace equation is uniquely determined if its value is a specified function on the boundaries of the region.